Hello and welcome to Vodcast 3.2. Our previous Vodcast covered weathering, mass wasting, and erosion, and we learned that a major component when reshaping Earth's surface is water. In this video podcast, we will overview the water cycle. Before overviewing the water cycle, it's important that we understand the three states of matter for water and how water can change from one state to another state. One of the many things that makes Earth awesome is the fact that water exists in all three states on our planet. Water can be a solid, which we call ice, it can be a liquid, and it can be a gas, which we call water vapor. What's most important for our discussion in this video podcast is understanding the processes of evaporation and condensation. Now that's not to say that the other four phase changes aren't important. We're going to come back to those because they will matter in future vodcasts. But for this vodcast, when we say evaporation, we mean that liquid water is absorbing heat energy from the sun, and when it absorbs enough heat energy, liquid water will change to water vapor, and that water vapor will join our atmosphere. Now, condensation is the exact opposite of evaporation. Rather than heat being absorbed, heat will be released, and water vapor will form liquid water if condensation is occurring. So the take-home point is this: evaporation is when liquid water absorbs heat energy from the sun and turns into a gas, and condensation is when water vapor will release heat energy, which causes it to cool down and change to liquid water. It's important that we understand that water is constantly on the move. Water can be found just about everywhere on this planet, and when we use the term hydrosphere, we are referring to all of the reservoirs where water is held. Water's found in oceans, in glaciers, in rivers, in lakes, in our atmosphere, in rocks, in soil, in plants and animals. We are literally surrounded by water and we can't escape it. The hydrologic cycle, which is also referred to as the water cycle, illustrates the movement of water between the ocean, the atmosphere, and the land. Just as the rock cycle was an extremely important visual that aided in the conceptual understanding of solid Earth, the water cycle helps us develop a conceptual understanding for how water moves around our planet. Take a look at the two pie charts shown to the far right of this slide. If we consider all of the water on planet Earth, 97.2% of that water is found in our oceans. So the overwhelming majority of water on planet Earth is salt water. Only 2.8% of the water on this planet is considered fresh water. And of that 2.8%, about 2.15% are locked up in glacial ice, while about 0.62% is found in groundwater. A very important note to make is that groundwater is the largest reservoir of fresh water that's available for human use. A very, very small percentage of Earth's water is found in lakes, streams, the soil, and the atmosphere, among other places. Let's take a detailed look at the water cycle. The water cycle is ultimately powered by the sun. Just as weathering, mass wasting, and erosion are all considered external processes, which means that solar energy is the ultimate force driving them, solar energy powers the water cycle. Let's start by taking a look at the ocean. Now, the ocean contains salt water, but solar energy is constantly hitting the surface of the ocean, and those water molecules at the very, very top of the ocean's water column can absorb solar energy, and if they absorb enough solar energy, those little liquid water molecules will evaporate and form water vapor. Once evaporation occurs, the water molecules are no longer part of the ocean, they're now part of our atmosphere. An important side note to consider is, when water evaporates off the surface of the ocean, the salt stays behind. It would be really bad if it was raining salt water all the time. Anyway, once water has entered our atmosphere, winds can move it over very long distances. And it's possible that water vapor climbs very, very high into our atmosphere. The higher that water vapor gets pushed into our atmosphere, the colder it'll get. And if it cools enough, that water vapor can undergo condensation. And if that occurs in our atmosphere, we'll see the formation of clouds. Clouds, as I'm sure we all know, produce precipitation. Precipitation most often comes in the form of rain and snow. And it's precipitation that brings the water that had initially evaporated off the surface of the ocean onto land. The precipitation can fill lakes and ponds. It can flow into streams and rivers. Through infiltration, some of that rainwater can soak into the ground. And through runoff, the liquid water can flow across Earth's surface. The process of runoff is our most important means of moving material from one location to another, because flowing water has the ability to do that, and to do that very well. Some of that precipitation that falls to Earth's surface can actually evaporate back into the atmosphere. Just as I'm sure you've probably seen in the summer a puddle of water form after a rainstorm and then it's magically disappeared a couple hours later, that water probably did one of two things. Through infiltration, it soaked its way into the ground, or as sunlight beat down on that puddle, the water evaporated and became part of our atmosphere. An important process that falls in line with evaporation is what's known as transpiration. Plants consume water during photosynthesis, but when they release that water back to the atmosphere, we call that transpiration. You can almost think of it as plants sweating, and it's important to note that the process of transpiration will add additional water vapor to our atmosphere. What's really fascinating about the water cycle is that it's balanced. The average annual worldwide precipitation is about the same as the worldwide evaporation and transpiration. Okay, that concludes this video podcast. I hope it helped you develop a good conceptual understanding of the water cycle. And for the rest of this chapter, our primary focus when taking a look at the water cycle is going to be runoff. The central focus of this chapter is landscapes fashioned by water. So by focusing on runoff, our primary objective is understanding how running water is reshaping Earth's surface.